Centroid is the intersection of all three medians of a triangle. Okay, so again, a median is a segment that does what? It connects the midpoint of a triangle to the opposite vertex. Okay, so what construction would we use to find the centroid? The midpoint, right? The midpoint is also perpendicular bisector. So we're going to do the exact same steps that we constructed the circumcenter. You're going to take your compass, place it on a vertex. Again, I'd compare it to the longest side. Make sure it's exaggeratedly longer than whatever the longest side is. And then construct your arcs. The arc should rotate. If you plan in advance, you'll be able to do all three of your constructions all at once. Okay, so here's my three intersecting arcs. And so now, in order to find the midpoint, I simply need to connect these intersections. And now, as I connect these and draw in these perpendicular bisectors, the part that I'm interested in isn't this intersection, although you guys see it, right? You can see here where that circumcenter lies. But the points that we're interested in, as far as this is concerned, we're interested in these midpoints. Because once we find the midpoints, we then need to connect those to the opposite vertex. Okay, so if I take the midpoint to the vertex, midpoint to the vertex, okay, I found my point. It's right here. Okay, I can confirm it by forming my final intersection. Okay, but right here in this intersection of these is our centroid. Okay. I had mentioned before a couple things about the centroid. It is the center of mass, or the balance point. Okay, so you could take any triangular shape like this. If you find the centroid, that's the point at which it would balance. Okay, and then we also saw that median is cut off in a 2-to-1 ratio. Okay, so we can confirm that here. If we take our compass and we measure the distance of the lower part of a median. Okay, so it's going to be hard to see because I'm using a light color, but here's the length. That means that this upper part should be exactly twice this length. So if we measure that, 1 and then 2, okay, we are able to see that it is in fact consistent with this ratio. We're able to construct to demonstrate that the upper portion is twice the length of the lower portion. Again, in terms of thinking of the ratio of 2-to-1, you can also break it down into the rule of thirds. So a ratio of 2-to-1 also means it's 2/3 of the whole versus 1/3 of the whole when you're looking to break it down.